January 19th, 11 minutes before the 0600 runway inspection window. Edmonton International Airport. Wind, 47 knots. Blowing snow, reducing visibility to near zero. Snowfall rate, 5 centimeters per hour and accelerating. An Oshkosh H-Series dual-engine snowblower has just made its third pass down runway 30. The blower head, 59-inch diameter, 5-bladed impeller, powered by a dedicated 670 horsepower Scania DC-16 engine, is throwing snow in a 60-meter arc over the runway edge lights. Is the speed of the throw fast enough to clear the cast zone before the next pass begins? The volume being moved, the equivalent of 5,000 tons of snow every hour. And still the snow is coming down. The control tower has already delayed 6 departures. Customs holds a full gate. Every minute the runway stays closed, the economics of this airport shift in a direction nobody wants. In the next 11 minutes, we go inside the machines that battle Canada's most extreme winter conditions. The motor graders, the blowers, the plows, and the people who keep critical infrastructure open when nature is trying to close it. This is not routine maintenance, this is industrial combat. If you enjoy watching real heavy machinery in action, bulldozers, excavators, and the machines that build the world around us, hit that like button. And if machines like these fascinate you as much as they fascinate us, consider subscribing to the channel. But we also want to hear from you. Have you ever worked around heavy machinery? Operated equipment like this? Seen machines like these on a construction site? Tell us in the comments. Many of the best stories in this community come from the people who have actually lived these moments. Now back to the story. But to understand how this operation unfolded, we have to go back. Canada has some of the most extreme winter weather on Earth. Not just in remote northern regions. In the cities, on the highways, at the airports, and along the infrastructure corridors that the country depends on every single day. Winnipeg regularly records temperatures below -40 Celsius, making it one of the coldest cities of its size in the world. Edmonton sees snowfall accumulation events that can deposit 60 centimeters in under 24 hours. The Coquihalla Highway in British Columbia, one of the most critical supply chain corridors in Western Canada, can be buried under avalanche conditions that halt traffic for hours at a stretch. The Trans-Canada Highway across the prairies faces ground blizzards that reduce visibility to zero within minutes of a wind shift. The consequence of losing these corridors is not inconvenience. It is economic damage measured in millions of dollars per hour for every hour that airports, highways, and supply chains are interrupted. This is why Canada runs some of the most sophisticated snow removal fleets in the world. Not just plows, not just graders, but purpose-built, high-performance machines engineered specifically for the conditions that Canadian winters produce. The snow removal fleet at a major Canadian airport can include 20 or more specialized vehicles. Each one is designed for a specific task in a choreographed clearance sequence that must meet Transport Canada standards for runway clearance time, typically under 20 minutes from the start of operations to a cleared, inspected, and reopened runway. 20 minutes. In a blizzard. With aircraft waiting. This is the engineering challenge at the center of Canadian industrial snow removal. And the machines that meet it are extraordinary. They are not adapted construction machines. They are not modified trucks. They are dedicated systems, engineered, certified, and operated to a level of precision that most people never see. Because most people are inside the terminal waiting for their flight to board. The Oshkosh H-Series is not a truck with a snow attachment. It is a purpose-built snow removal vehicle, a machine for which there is no peacetime equivalent and no civilian counterpart. The H-Series chassis was developed by Oshkosh Corporation for the specific demands of airport snow removal. The company has been building heavy-duty all-wheel drive chassis for snow removal for more than 80 years. A lineage that traces back to the 1940s when airports were just beginning to understand what large-scale winter operations actually required. The current dual-engine blower configuration runs 2 separate powertrains. The drive engine propels the machine. The blower engine, a Scania DC-16 producing 670 horsepower at 1,800 revolutions per minute, powers only the blower head through a dedicated drive line. These two systems operate independently, which means the operator can modulate blower speed separately from vehicle speed to optimize both clearance rate and snow cast distance. The blower head itself is a 59-inch diameter, 5-blade impeller assembly. Housed in a curved auger intake, the system gathers snow at the leading edge, accelerates it through the impeller, and ejects it through a rotatable discharge chute. Chute direction and deflector angle are controlled from the cab, allowing the operator to position the snow arc precisely over runway edge lights, clear of aircraft holding areas, into designated snowbanks. Cast distance reaches up to 60 meters under ideal conditions. The H-Series also features Oshkosh all-steer, an all-wheel steering system that allows the front and rear axles to steer independently. On an airport taxiway or runway, where lanes are defined to the meter, this steering capability allows the operator to track the exact center line without overcorrection. The cab is designed for extended winter shifts. 40% more glass than conventional snow removal vehicles. No corner posts obstructing sightlines. Digital climate control rated to extreme cold weather operation. Everything visible, everything controllable, everything accountable. The snowblower clears volume. The motor grader controls the surface. In any major snow removal operation, whether at an airport, along a Trans-Canada highway corridor, or across a northern municipal network, the motor grader is the machine that determines the final condition of the cleared surface. It is the precision instrument at the end of the heavy equipment chain. The Caterpillar 163H has been one of the primary highway and airport motor graders in Canadian operations for decades. It runs a 220 horsepower Cat 3 176C turbocharged diesel engine and carries a 14-foot mold board, 4.27 meters of blade steel engineered to follow road contours with millimeter-level precision. The 163H's all-wheel drive system is critical in snow operations. When engaged, variable horsepower automatically delivers maximum power across all gears, necessary when the blade encounters a compacted windrow, a pressure ridge of ice-hardened snow, or the resistance of drifted material that has partially refrozen. The blade float function is the feature that separates a grader from a plow in surface quality. By floating both blade lift cylinders simultaneously, the mold board follows road contours under its own weight, moving with the surface rather than against it. This means the blade conforms to ruts, crowns, and ice ridges without the operator manually adjusting blade height on every pass. In mining operations and on highway corridors carrying heavy truck traffic, the Caterpillar 24M takes over. Launched in 2007, the 24M is one of the largest production motor graders ever built. It carries a 24-foot mold board, 7.3 meters, and weighs approximately 145,000 pounds. The C18 Acurt engine delivers between 518 and 533 horsepower depending on configuration. At an oil sands mining operation in winter, a fleet of 24Ms runs around the clock maintaining haul roads that carry 400-ton trucks. One soft spot, one rut, one ice ridge, and the haul truck cycle time climbs. Beyond the airports and the mine sites, the snow removal challenge scales to every road in Canada. Provincial highway departments across the country operate fleets of tandem and tri-axle plow trucks fitted with underbody scrapers, front plows, and wing plows that can clear a full highway lane width in a single pass. In Alberta alone, provincial highway maintenance contracts cover more than 30,000 kilometers of roadway. The machines doing this work are purpose-configured for extended winter operation. And a highway plow truck working a northern Alberta corridor in a blizzard typically runs for 12-hour shifts, making continuous passes on the same section of road. The operator never leaves the cab. The machine never fully stops. The mechanics of a good highway plow pass are more complex than they appear from the road shoulder. The front plow breaks the fresh snowpack. The wing plow, deployed at an angle of 30 to 45 degrees, rolls the broken snow into a windrow at the road edge. The underbody scraper, a hardened steel blade mounted beneath the truck frame, follows the road surface and removes the bonded layer of ice and compacted snow that forms when traffic and temperature interact. The underbody scraper is the part of the operation most drivers don't know about. It is also the part that determines whether the road is truly clear or merely plowed. A highway with a packed snow base can have traction conditions indistinguishable from black ice. In municipalities, the wheel loaders, machines like the CAT 980 or Volvo L180, are deployed to move windrows away from intersections and load snow into dump trucks for transport to designated snow disposal sites. The clearance of a single urban city block in a major snowfall event can take multiple passes over 6 to 8 hours. Every machine in this story has a person at the controls. Snow removal operators in Canada, whether at airports, on highways, or across municipal networks, work shifts that frequently stretch beyond 12 hours during major storm events. The work is monotonous in its repetition and dangerous in its conditions. Zero visibility, ice-covered roads, other vehicles, all at the same time. Airport snow removal operators work under a specific pressure that most equipment operators never face: time. A runway must be cleared and inspected before it can reopen. The clock is running from the moment the first snowflake affects surface friction. Every second of delay carries a direct operational cost. The certification requirements for airport snow removal operators are rigorous. Equipment type training, airside safety certification, runway marking systems understanding, radio communication protocols with control tower, and meteorological awareness are all part of the qualification. These are not general heavy equipment operators. They are specialized roles with airport-specific licensing. On highway patrol, the experience required is different, but equally demanding. Reading road conditions across a long route, knowing which sections will drift first, which grades will ice before others, where the temperature inversion begins and the chemistry of anti-icing changes, requires years of operating in the same corridor. An experienced highway operator becomes a road weather system unto themselves. They are not waiting for the road sensor network to tell them conditions have changed. They already know, because they have been watching the same sky on the same road for 20 years. When the snow stops, or slows enough that operations can catch up, the runway reopens. The grade is restored. The highway is passable. The intersection is clear. The immediate result is visible. Aircraft taxiing, trucks rolling, cities moving. But the broader consequence of this work is less visible and more important. Canada's ability to function as an integrated economy through its winters depends entirely on the reliability of its snow removal systems. Supply chains that feed every major city, hospitals that receive medical equipment, airports that connect communities to the world. All of it depends on machines and operators that most people never think about. The long-term impact is also about the machines themselves. The Oshkosh H-Series has been refined over 8 decades. The Caterpillar motor grader lineage traces back to the early 20th century. These are not technologies in development. They are technologies in continuous refinement. Each generation more capable, more efficient, more precise than the last. The modern relevance is this. As Canadian winters become more volatile, with more intense precipitation events, more freeze-thaw cycling, more unpredictable storm patterns, the demands on snow removal equipment will increase. The machines will need to be faster, more fuel-efficient, and more data-integrated than anything currently in the field. That work is already underway. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.